Hello everyone, welcome back to our channel Problematical. Today we'll discuss exercise 3.3's second part from chapter 3 Trigonometric Functions, class 11th Maths NCERT. Now this question has an LHS and RHS. The main question was to prove this equation. That means to prove that LHS is equals to RHS. So in this question also the numerator is of the form sine A plus sine B upon cos A plus cos B. So your LHS is equals to sine x plus sine 3x upon cos x plus cos 3x. Now we know that sine A plus sine B. I'm directly applying the formula because the formulas have already been covered and you should have memorized it by now, but you can find it in your text. So sine A plus sine B is sine 2 times sine A plus B by 2 into cos A minus B by 2. So it is 2 times sine 3x plus 4x, 3x plus x upon 2 into cos x minus 3x. That means A minus B upon 2 whole upon cos A plus cos B is 2 times cos A plus B upon 2 into cos A minus B upon 2. Now this will be 2 will get cancelled and this is equals to if you can observe this term is equal, these two terms are same, they'll be cancelled. Sine 4x divided by 2 is 2x. So this is sine 2x upon again x plus 3x 4x divided by 2 is cos 2x. Sine 2x upon cos 2x is tan 2x, which is your RHS. Next. Again, you have to apply the similar formulas. Your LHS is sine A minus sine B, and denominator is A square minus B square. So let's apply the formula in the numerator only. 2 times cos of A plus B upon 2 into sine of A minus B upon 2. Now the denominator is sine square minus cos square. This is A square minus B square. It can easily be split into A plus B into A minus B, or you can apply double angle formula. We know that cos 2x is equals to cos square x minus sine square x. Amongst its three formulas, this is one of the formula. Cos square x minus sine square x. Here we have sine square x minus cos square x, which can be written as minus 3 times minus cos 2x minus cos 2x. So solving the numerator, 2 times cos of 4x divided by 2 cos 2x into sine minus 2x divided by 2 is minus x upon 2 minus cos 2x. Again cos 2x get cancelled. This minus sign is in the numerator, minus 2 sine 2 minus x. This minus 2 sine minus x is minus sine x. So minus 1 gets plus 1 and you're left with 2 sine x. This is your RHS. Next. Here you have cos 4x plus cos 3x plus cos 2x. Now whenever you have such kind of angles, this is 4x, 3x, 2x. You just merge up the even angles and or merge up the odd angles. If you have an option between even and odd angles and the angles are more than 2. So I'll consider the LHS is equals to cos 4x plus cos 2x. I'm interchanging second and third terms, positions, cos 3x, and I'll be applying the formula in the bracket first. Similarly, in the denominator, I'll take even angles separately. If I apply the formula, it is 2 times cos of a plus b by 2, 4x plus 2x divided by 2. 4x plus 2x is 6x divided by 2 will give you 3x into cos of a minus b. Cos of 4x minus 2x divided by 2. Cos of 4x minus 2x is 2x. So cos of 2x divided by 2, which means it is cos x plus cos 3x whole upon sine 4x plus sine 2x. This is 2 times sine of a plus b by 2, which is 4x plus 2x, 6x divided by 2 is 3x into cos of sine 2x, sine 4x, a minus b, which is 4x minus 2x is 2x divided by 2 is x plus sine 3x. So you'll take sine 3x in common in numerator, cos 3x in common in numerator, you're left with 2 cos x plus 1, and you'll take sine 3x common in the denominator, and you're left with 2 cos x plus 1. These two brackets get cancelled, they're the same value. Cos 3x upon sine 3x is cot 3x. This is your RHS, hence proved. Next. So your LHS is equals to cot x into cot x into cot 2x minus cot 2x into cot 3x minus cot 3x into cot x. Now we have the formula for cot a plus b. Also, amongst these three terms, you can take common between any two terms. Let's consider these two terms because there's a minus sign can also be taken as common. So you have cot x into cot 2x, and you're taking minus cot 3x common. We'll be left with cot 2x plus cot x in the bracket. Now, we know the formula that cot a plus b is equals to cot a into cot b minus 1 upon cot a plus cot b. This 3x over here can be written as 2x plus x. So you can write this 3x as cot 2x plus x. So you took cot 3x common, and instead of writing 3x, you're writing 2x plus x. This can be considered as a, and this can be considered as b, and you can apply cot a plus b over here, the formula. So you have cot x into cot 2x minus cot 2x into cot x minus 1 upon cot 2x plus cot x. Cot 2x plus cot x. So we did that so that we can get these two terms cancelled out. Now we are left with cot x into cot 2x. So you've completely eliminated the 3x angle, and you're left with only 2x and x angles. 2x into cot x. Minus sign is introduced, so this is minus and this becomes plus 1. These two terms are same, gets cancelled, and you're left with 1, which is your required RHS. All you have to do is take common from the second and third terms, represent this 3x in terms of 2x and x, and come up with the answer. You can also try this question by taking this cot 2x common from the first and the second terms, and then approaching it. This is your RHS. Next. One second. Okay, tan 4x is equals to 4 tan x 1 minus tan square x upon the denominator. Now, what can we do with tan 4x? Tan 4x can be represented as tan 2x into 2x. We have the formula for tan 2x, right? tan 2x is equals to 2 tan x upon 1 minus tan square x. This we know. And you can represent tan 4x as tan 2 times 2x. Now, if here tan 2x is this value, that means if you have a double angle here, you have a single angle on the right hand side. This double angle means single angles on the right hand side. So your double angle means this is your single angle on the right hand side. So you're applying the formula, you'll get 2 tan of 2x upon 1 minus tan square 2x. All you have to do is apply tan 2x formula again. So this is 2 times tan x upon 1 minus tan square x upon 1 minus 2 tan x upon 1 minus tan square x whole square. This is equals to 2 tan x upon 1 minus tan square x whole upon 1 minus tan square x whole square. So this whole square will be divided into numerator and denominator. We'll be left with 1 minus tan square x whole square minus, this is 2 tan x whole square, it is 4 tan square x divided by 1 minus tan square x whole square. So this is your original denominator. So this part will go upstairs and you'll be 2 tan x into 1 minus tan square x whole square. This part will be multiplied in the numerator whole upon 1 minus tan square x gets cancelled with this, and this whole term over here, which is 1 minus tan square x whole square minus 4 tan square x. So we're left with 2 tan x 1 minus tan square x in the numerator, which is your what did I miss? Yeah, 2 times 2. 4. So first 2 was from the first formula and second 2 was from the second formula. Here in the denominator, you have 1 minus tan square x whole square minus 4 tan square x. Let's solve it separately. So 1 minus tan square x whole square minus 4 tan square x. This is equals to 1 minus tan 4x, 1 plus tan 4x minus 2 tan square x minus 6 tan square x. So what you've done is you've applied a minus b whole square. This is 1 minus 4. After calculation, it will be 6. These two minus 6 tan square x plus tan 4x. So this value can be written in the denominator. 1 minus 6 tan square x plus tan 4x. Tan 4x means tan to the power 4x. This is your RHS. Hence proved. Next. One second. Yeah. Next question. Cos 4x is equals to 1 minus 8 sine square x into cos square x. So what do we have here? You have to prove this. If you observe the right hand side, you can see that here you have 2 sine x into cos x whole square. So either you can solve it by right hand side, or you can apply some formula on the left hand side, because you have double angle for cos. You have 3 formulas for double angle of cos. You need, let's solve the right hand side first. We'll see. We'll try to solve it from both, considering right hand side first and then considering left hand side first. So let's solve it in both methods. So I'm considering the right hand side first. This can be written as 1 minus 2 into 4 sine square x cos square x. This can further be written as 1 minus 2 sine x cos x whole square. I'm taking square outside. This is 1 minus 2 sine 2x whole square. Or I can write this as 1 minus 2. This is sine of 2x, angle is 2x whole square. So sine square 2x. Now we know that cos 2 theta is equals to 1 minus 2 sine square theta. The right hand side looks something like this. So if I put theta is equals to 2x in this equation, I'll get cos of 2 times 2 theta, 2 times 2x is equals to 1 minus 2 sine square 2x. So your right hand side is equals to something like this. Is equals to cos 2 times 2x, which is cos 4x. This is your LHS. This was you when you considered RHS, solved it, or took something common and then solved it, and then ended up with your LHS. Now let's try and consider the LHS first. So your LHS is equals to cos 4x. Again, cos 4x can be written as cos of 2 into 2x. This is, let's let 2x is equals to theta. So this is cos 2 theta. Cos 2 theta is equals to this formula, 1 minus 2 sine square theta. Now again, I'm resubstituting the value of theta over here. So 1 minus 2 sine square 2x. This is again 1 minus 2 times sine 2x whole square, which is just the reversal of the steps that you carried out previously. 2 sine x cos x whole square, 1 minus 2, 4 sine square x cos square x. This is equals to 1 minus 8 sine square x cos square x, which is your RHS. Hence proved. Next, this is the last question for this from this exercise. Cos 6x is equals to, on the right hand side you have like 4 terms. So we know that cos 6x can be written in double angle form. We're trying to reduce this. We do not want 6x on the right hand side. We need the angle to be a single x on the right hand side. So let's get rid of 6x, or try to get rid of 6x. Your cos 6x is equals to cos 2 times 3x. Okay, or you can write 3 times 2x. So either you can apply double angle formula or you can apply triple angle formula. Let's apply triple angle formula first. So triple angle formula would be 3 times 2x. And here we are considering that 2x is equals to theta. So this can be written as cos 3 theta. Now we know the formula of cos 3 theta is 4 times cos cube theta minus 3 cos theta. This is the formula for cos 3 theta. Now again, resubstituting for theta is equals to 2x. So 4 times cos cube 2x minus 3 times cos 2x. You do not want any sign on the right hand side. So you will have to apply the formula for cos 2x or cos 2x, which is only in terms of cos, which is 2 cos square x minus 1. There are 3 formulas for cos 2x. The other 2 formulas involves a sign terms in it. We do not want a sign term. So we'll apply this over here. So this is 4 times cos 2x whole square. So cos 2x means 2 cos square x minus 1, and you're taking the whole square, minus 3 times 2 cos square x minus 1. This is 4 times a minus b whole square, a square, minus, hold on, did a, oh, this is a cube, not a square. So we'll have to apply the cube formula, sorry. This is cube. This should be cube. So a minus b whole cube is a cube square x whole cube. So a cube minus 3 times a square b minus 3 times a b square. This should be plus minus 1 cube minus 3 into 2 is 6 cos square x plus 3. This is equals to 4 times. Now I'm introducing 4 as well in the bracket. So 2 cube is 8. 8 into 4 would be 32. So this is 32 cos square cube means cos to the power 6x minus 4 into 3, 12 into 2 square 4. So 12 fours are 48 minus 48 cos squares square is cos to the power 4x plus 4 into 3, 12 into 2, 24 plus 24 cos square x minus 4, 3 into 1 cube, 4 minus 6 cos square x plus 3. So this term will merge with this and this term will merge with this. So you have 32 cos to the power 6x minus 48 cos to the power 4x, 24 cos square x minus 6 cos square x is equals to 18 cos square x plus minus 1, which is your RHS. This concludes this exercise. Thank you.